Okay, let's do some more examples with the for loop. So consider if we have for int I equal to 5, and I want I to be greater than 0. So do this while I is greater than 0. And then the update statement. So we've got to do something to I. And then I'm going to make the block pretty simple. So simply just print I at each iteration. Now let's draw the memory diagram. And so we have I, which is set to 5. So we want to be really correct about this, the memory diagram. So we're going to have, while the for loop is alive and running, I is set to 5. Now we're going to have cancel down here. So if I set I plus plus, that means at each iteration I is going to increase. So I is going to be 6, then 7, then 8. So I is always going to be greater than 0. So if this is plus plus, this is going to be an infinite loop, which is not what we want. We want to try to avoid infinite loops. So instead, but if we have I minus minus, that means that each iteration I decreases. So it will be 4, 3, 2, and it will eventually approach 0, at which case we drop out of the loop. So let's go through this. First is 5. 5 is greater than 0. And we're going to output 5. And then don't forget that this is actually going to execute as the last line in the for loop, right? So then I is going to become 4. We'll go back up, and don't forget we're not going to initialize anymore. So is 4 greater than 0? It is. So we're going to go in here and we're going to print I, which is 4. Then we're going to decrement again. We get 3. We go back up. Is 3 greater than 0? It is. So we're going to go in. We're going to print 3. Right? Then then we are here, so we're going to decrement again. So I'm just going to erase what's inside of here. So now this is going to become 2. We'll go back up. We're not going to be touching the initialization. Is 2 greater than 0? It is. So we're going to print again. So 2 is going to be printed. And when it's printed, then we'll do I minus minus. So this is going to be 1. We go back up. Is 1 greater than 0? It is. So we're going to go back up and print 1. And then we do I minus minus. So I actually becomes 0. And we go back up. Is 0 greater than 0? It's not, and we get out of the loop. And the output is going to be 5, 4, 3, 2, 1. And the loop is actually going to run 5 times. Okay, let's look at a different type of for loop. So sort of a different kind of an example involving chars. So let's say in this for loop, we have a char starting at A, and we want to keep going until you hit G, and you add 1 to start at each iteration. What would be printed? So maybe pause the screen and actually think about this for a second, and start the video back up when you have an idea of how this is going to work. So here, if I draw the memory diagram, we're going to have setup. Inside of setup, 4 is running, and we get start. And start, so it begins, start is less than, start is set to capital A is less than capital G. So we're going to print start. So print, so in our console, I'll just do it over here. A is printed. Then start plus plus happens. So this actually becomes B. We go back up. We don't initialize anymore. We say, is B less than G? It is. So we're going to go into the loop and we're going to print start again, which is B in this case. And we keep on doing the same thing until we get the output of A, B, C, D, E, F. So before we get to G, before we get to G, we're going to get out of the loop, because G start can never be G and to go into the loop. After the for loop, of course, start does not live anymore. But at the very end, it becomes G. You go back up. Of course, start can't. It must be less than G, so you get out of the loop. So hopefully, this is clear for everybody as well. So a couple cool things about the for loop. First of all, let's go through this once more. In a for loop, you have initialization, you have the check or the test, and you have the update. You have your statements inside. One thing that you could actually have multiple variables. So you could have multiple initializations. So here I have I and J. You could have multiple tests as well. Here I have one test as long as I is less than J. And I have two updating expressions, I plus plus and J minus minus. And some sort of thing happens here, some sort of an, whatever statements you would like to display. So let's look at this example. Actually, first of all, before we go, notice the difference. So the initializations, they're separated by commas. The test expression, then you have semicolon, and then the updates are also separated by commas. So you have three categories: initialization, test or check expression, and then updates. If you have more than one of each kind, they are going to be separated by commas. They are separated from each other by semicolons. Let's look at this particular example. Here we have I and J, and then you have I must be less than J, I plus plus, and J minus minus. So let's see what the output of this is going to be. Let's draw the memory diagram. So here we're going to have I and J. So I'm going to draw this kind of big so that I don't have to erase and I can just cross things off. So let's say I is at 0. And let's have our console over here. So at first we set these, we go and we say, is I less than J? I is less than J because I is 0, and that's, so we're going to print 0 and 5. Then we go back up. Sorry, so then we're at the last line. The last line is where all the updating happens. So I becomes 1 and J becomes 4. We go back up, and so we don't do initializations, we only do the check. I is still less than J, so we're going to print what we have, which is 1 and 4. Then we do the updates at the very last line. So it's going to be I plus plus, I is going to become 2, J is going to become 3. Okay, so we go back up. I is still less than J, so we're going to come and print I and J as 2 and 3, and then we're going to add I plus plus, so I will become 3, J minus minus, J will become 2. So then we go back up and we'll look at this. We say I is less than j. It's not anymore, so we get out of the loop, and this is the output. So this loop runs 3 times. So this is a pretty valuable example. So like, let's say in an exam situation, or even in one of my quiz questions, I ask you that how many times does this particular loop run, and you should be able to work it out. If you are good with memory diagrams, which you should be, we've done a ton of them, you should be able to figure things out quite easily. It's just the trick is just go in order, and things will work out. So let's look at this calculation and execution time. So we have I0 set at 0, and I is less than and equal to 5. So if it's less than and equal to 5, that means that it's going to run how many times? It means that it's going to start running at 0, 1, 2, 3, 4, and 5, and then it becomes 6, and 6 cannot be. So this actually runs 6 times. This is quite important, so make sure you account for the equal sign here. So if the equal sign wasn't there, what would be printed was 0, 1, 2, 3, and 4. Here are a couple of rules. If you have the equal sign in here, then the loop is called symmetric, or it has symmetric bounds, and it would run b minus a plus 1 time. So that's a cool formula to remember. I'm just gonna go through these pretty quickly and leave it to you to go through them, just because they're simple formulas. If it is asymmetric, that means it doesn't have an equal sign here, then the loop will go through it b minus a times. So if this was 0 and this was 5, this loop would run 5 times. If there was an equal sign here, it would be basically 5 minus 0 plus 1, which is 6 times, right? You could always take bigger steps in your loop, so you don't always have to say I plus plus. You could also have I plus 2 or I plus 20 if you want it, and that works just as fine. So here it's going to be 0, 2, 4, 6, 8. Of course, I must be less than 9, so then after that you leave the loop. A bit of warning, you almost never want to use your check argument as a not equal to, because not equal to only checks for one value. So if you use not equal to and run and go and basically take bigger steps, you're going to pass 9, because what you're going to get is 0, 2, 6, 8, and then you're going to get 10. So you're never going to get I as 9, so this is not going to terminate. You're going to have an infinite loop on your hands. So this is something that you have to definitely watch for. Basically, the equal and not equal are best avoided when you're doing for loops. All right. You could even take bigger steps. So for example, you could use other sort of update statements here. So for example, here we are saying I times 2 at each iteration. So this is going to be 1, 2, 4, 8, and 16. So I is being updated. It's not being incremented, but it's going to be a multiplication of 2 each time. That's pretty much what I have with regards to the for loop. So I'm going to do a tutorial on for loop and drawing some shapes in processing. So I'll upload that as a tutorial to use it to draw some shapes using a for loop in processing. The last loop that remains that we still need to do is the do while loop. And the do while loop, the main difference here is that the do while loop is a post condition loop. So this is a post condition. What this means is it actually runs the loop block at least once before checking for any condition at all. It's a post condition or a post test loop, and the way it goes is that you have a keyword named called do, and then you have your block, the statements go there, and then you have your while test condition, and you actually must have semicolons at the end of do while. So the syntax is quite a bit different as well. This way, the conditions, the block runs at least once, even if the condition doesn't match. It runs at least once, checks for condition. If the condition is true, it goes back to the top. If the condition is true, it goes back to the top. And if it's false, it'll go to the rest of the code. So here you see sort of statements. This is do. This is basically the block, the test condition. If the test condition is true, you go back up. If it's false, you drop out of the while loop. And here is basically the steps that I have said. The updating happens here typically, and here is the while expression. Now let's do a quick comparison between the while and the do while and the for. So originally we had int, we had the while loop, and so print ln I, and then of course we have I++. Then we have the for loop, which was int I = 0, I less than 5, I++. And here we could just say print ln I. So both of these, what they would print out was 0, 1, 2, 3, 4. The do while would of course be as such. So you're going to have do, actually, so we're going to need an int I, then we have do, and inside of here we're going to have print ln, which is our statement, I++, oh, too many pluses, and then here we're going to say while I is less than 5, semicolon, do this. So all three of these will do the same thing. Notice the difference though. If I came all of a sudden and I said, well, first of all, let's look at the components of the loop. So you have initialization 1, you have the test condition, you have the update 1, 2, 3. Here you have the initialization, then you have the condition, and you have the update 1, 2, 3. Here again you have the initialization, you have the update, and you have the condition at the bottom. So I've numbered these wrong then. So this is 1 for initialization. Number 3 is for the update. So update is actually number 3. And number 2 would be number 2 because number 2 is the check, right? So 1, let's do like it. So 1 is initialization, 2 is test condition, and 3 is update. So that's how they look like. These two particular are preconditions. This loop alone is post condition. And of course, the other difference is that let's say I change all these loops. So let me choose a different color. Let's say if I changed all these loops in such a way that I made this 10. So I initialize I as 10. So I 10. And I'm going to change this at I as 10. So everybody's with me. So I just changed the initializations to 10. Let's see what the output is going to be. All right, I crashed for a second, but it seems to be, uh-oh, that's not what I want. Back on. Okay, let's see what the output is going to be. Here, I is 10. Then we say while I is less than 5. Well, I is not less than 5, so this is not going to be executed at all. No output. For the for loop, I am saying I is 10, and then I'm saying is I less than 5. It's not, so no output here as well. Here, I is 10, and I'm going to execute once. So the output for the do while over here, the output is actually going to be 10 because I'm going to print this at least once, and then I'm going to increment I. It's going to be 11, and then I say while I is less than 5, 11 is not less than 5, so I'm going to drop out. So you see, for the do while, because it happens at least once, the output is going to be 10. So this is the major difference between the do while and the for and the while loop. So you have the overall structure of this and this example that I just did. They're all in the slides, so make sure to go through it.